All right, so remember, I'm not gonna give you the formulas, but I will give you the formulas, excuse me, but I'm not gonna tell you what each of those variables stands for. So you've gotta make sure you know what B and R and S sub Y and Y bar and all of that stands for, right? But then you are truly just plugging into those formulas. You're gonna solve for B first, because that's your slope, and you need that value in order to plug in to find your y-intercept, right? Okay, so down here we plugged in our data. We did one variable statistics to find our mean and standard deviation for both our x's and our y's, and then we used the a plus bx formula on the calculator to find our r, and then you plugged in. So what did we get for B? 0.3441. Sounds good. That's our B. For A, what did we get?
76.26.
70. Oh, I got
71.09.
yeah, 71.09 if you round to the hundreds.
Aw, dang.
That's what I got.
Check your math. Guys, here's where it's important. Like if you're just putting a number and you make a mistake with how you're plugging in, I can't give you any credit. If you are showing me steps though, and you are showing me that you are plugging in, and to find what A is, you're doing 78.83, 83 minus 0.344 times 22.5, and you've just plugged in wrong, I'm gonna be able to give you some credit. But if you just put a number there, it's all or nothing. Don't put me in that position. And don't put yourself in that position, right? So y is equal to 71.
0.0908 plus is 0.3441
X. Beautiful.
Can I do it the other, like the other
Awesome.
out of the order?
Yeah, does not matter the order.
Great to hear.
Correct.
I'm assuming this is due by the end of class, all this stuff.
Aiden.
That's just kind of notes and review and practice. We're gonna look at the next one too, that other sheet that says example and practice with graphing calculator and drawing an equation of least squares regression line.
Oh, I found
We're gonna work through this too. And then I'm sending you to the windows, and then we'll talk project, and then you guys are gonna work together on the worksheet, and I'll explain about that. Okay,
I'm feeling the windows today.
all right.
This out. Oh, never mind.
Following data shows fuel economy for 10 vehicles. Explanatory variable is engine size. Response variable is combined gas mileage expressed in miles per gallon. Find the regression equation on your calculator. So plug that in. What do we get?
Just like asking for you.
Yeah, I'm writing this both ways because you guys keep asking me if that's okay. So I don't care either way. The key is making sure you have the correct signs, right?
Correlation coefficient.
So minus 5.488x, right? Okay, correlation coefficient is what?
Negative 0.9584.
9584. Okay, so we have our equation. Jack, were you able to get that figured out? Okay,
It's okay, we're here for
all right. Jonah, Vishal, you got that equation?
this, man.
Okay. Jack, should we look at that? Is it just something with the plugging in that you did?
I would say that,
Did you press enter while you were still in the number?
Vishal, hush. Let him focus and concentrate and be able to, that's probably part of the problem is y'all keep talking and he can't concentrate. Okay. Another question for you. What is r squared, guys?
Correlation squared.
Great. What is the value?
Oh, yeah, exactly what Jonah said.
0.917764. Okay. Tell me what r squared means. There's very specific language you're supposed to use, yes?
Great question.
So 91.7764%. That's all I'm going to say. The rest of it needs to come from you guys.
Percent of
Of the what?
of the values.
no.
Pull out your notes if you need it. It's in the back, very last page of your notes. You have to know how to write this and say it, or you will lose out on mucho points. Mucho points.
How else did you say points in this thing?
Puntos, I think. 91.7764%.
Talk about. Oh, wait a minute. 91.76%. That number
Okay,
of the relationship between miles per gallon and what was it? And engine size.
between engine size
can be-
and miles per
shoot, I got it
gallon
mixed up.
and combined miles per gallon.
Oh, I'm sorry. I thought it was.
Keep going.
Can be explained by the least squared regression line.
Can be explained by the least squares regression line. And I'm okay with you
Yippee.
abbreviating least squares regression line with that LSRL.
LSRL.
I'm totally fine with that, but you need to be able to explain what R squared tells us very specifically. All right, last question on this before we move on to the next page. Does the y-intercept have meaning in this context? Go back and think about what the y-intercept is.
No, because there's no such thing as a zero engine size.
Okay, yeah, that would imply an engine size of 0 having a combined miles per gallon of 38.4065.
What do we
That does not make sense,
There's
right?
no such thing as a
No
engine
context.
horsepower.
Oh, wait a minute.
For
Electric
y-intercept,
vehicle.
right?
They don't have any miles per gallon.
They have a displacement 500.
Shoot.
Okay,
miles per kilowatt.
so now here's where we're really going with this. Back page, next page.
Oh, it looks to be completed for it.
I have graphed the graph for you so you can see what the graph looks like, right? It's labeled. It's not real clear, but I've graphed the graph for you. If you have an equation, which we do now, we are given that we decided that the equation was y is equal to 38.4065 minus 5.488x, right? If I ask you to graph that least squares regression line on your scatter plot, there's a very specific process that I'm going to expect you to do. If you notice, it says you need to choose two values, two x values, one low and one high. Plug into the equation and find the corresponding y value. So for this particular set of data, we would need to choose an x value that's low, probably at about 1.5. So let's plug in x equals 1.5. Let's choose an x value that's on the higher end. How about 4.5?
Oh, shucks. Oh, I see what you're saying.
So that's about right here and right here, right, on our graph. We're gonna plug in, we've gotta show the work for plugging that value of x into this equation. So that means we're doing 38.4065 minus 5.488 times 1.5. I need to know that answer, and then the second one also. So what do we get? Okay, so we did the math, plugged in x is 1.5, got the corresponding y value, did the math for x equals 4.5, plugged in, got the corresponding value. We're gonna graph those two particular points. We need to use some type of a mark other than what we see here, right? We shouldn't use a point just like they did. So at 1.5 and 30 point something,
Basically exactly where that dot is.
it's pretty close, but it's a little bit to the left of that point there, I would say. And then this 4.5 is at 13.7, so it's just below there. So I've drawn two little small X's to mark where those 2 points are. Those are points on our regression line, and then you play connect the dots. Hopefully straighter than what I just drew. But you get the general idea.
Oh, wow.
Okay, but there's work involved here of showing me, choose a low value for X, choose a high value for X, do the work, plot those points and play connect the dots.
Instead of guessing, can we do this?
That's what you have to do.
No, because remember how you said just eyeball it sometimes?
That's line of best fit, but if you're drawing in the least squares regression line, this is the process that you're gonna do.
Goodbye.
Good question. Right, does that make sense? Okay, notice here, you're given a set of data, right? And You're welcome. You were also given the regression line, so you don't have to actually plug in the data and actually do that figuring. But that's not the tedious part about this anyway. It's the residual part that tends to be more tedious. So you have the equation for the line of best fit. Here's your scatter plot for that as well. They've drawn in the residual already, which was nice of them, but you have to go through the process of figuring out what the residual is. So once again, reminder, what did you say, Aiden? You find the residual by doing,
The actual value minus the predicted value.
okay. So I wrote that down here up at the top. You may want to put that in there just to help you remember and think about what it means you have to do. So you're given your set of data, right? And then you're given this equation. It means you have to plug in this value for x into this equation to come up with what the predicted value would be. So that's how this 76.357 got
It
there.
would be negative 0.357.
Correct. So then you would do actual value minus the predicted value. And yeah, on this one, you end up with a negative 0.357 is what that would be. Okay? You're not going to do that first table, though.
Yeah.
And there's a reason why the desks are set up this way. This gets long and tedious, so you guys are going to break up the work down here so that you're not having to do quite as much. So first thing we're going to do is you're going to turn over to look at number 3.
Number 3.
Okay? Because notice on that one it's saying you have to find the equation first. So you need to plug in the data for x's and y's. You're going to all do that because we want to verify that we have this right equation. So plug in that data. We're going to verify that we're all working with the same equation. And then I'm going to divide up and say, okay, Jack, you're going to do the work for these questions. You're going to do these. You're going to do these so that you're not having to do all of this because, like I said, I know it gets tedious.